So this was the last example we did in the last class. I'm going to begin there and redo that just to make sure uh, everybody is with me. And also I'm going to use this example to illustrate some other examples. So let's clear the board and I'm going to do this example, which is adding up all the odd integers from 1 to 30. To generate all the odd integers, I can begin at 1, the first integer, first odd integer, and then if I keep adding 2, then I'll get all the other odd numbers. So I'll begin my program by saying int n equal to, n is my variable for the odd number. The odd number is going to be held in the n. So int n equal to 1, the first odd number. And then while n less than or equal to 30, n has to go up to 30. For all those n's, I need to add them up. So I'll go back and introduce the variable sum set to 0. And then inside the loop, I need to do sum equal to sum plus n. And after that, n needs to change. So always add the current value to the sum and then change the n to prepare for the next round of the loop. So I need to change the n by 2, n equal to n plus 2, and that'll do it. When initially n is 1, and so let me trace that program. Sum is initially 0, n is 1, and here I'm adding the 1 to sum, so sum has a 1 now, and then n changes to 3, n is now 3. And with the 3, we go up, and as long as n is under 30, I'm adding the 3. So sum to the current sum, I'm adding 3. So I'm adding 3 to the 1. So sum now has 1 plus 3. And then the n changes here to 5. Go back to the top, n less than 30 is true. So now I'm adding 5 to sum. So now sum has 1 plus 3 plus 5. But that's why you had to do it this way. Sum plus n. To the current value of sum, you're adding the new number and putting back in sum. So that way sum now has 1 plus 3 plus 5. And then the n changes to 7. And next time through the loop, I'll be adding 7 to the current value of sum. And you can see that it'll work. Eventually, when n becomes 30, I have less than or equal to say when n is 30, still do the addition, and then n become 32, and that's when the loop terminates. So all the numbers through 30 will be added. Okay, now if I want to, it's a problem says write the program to add 1 over 1 plus 1 over 3 plus 1 over 7. In other words, reciprocals of all the odd numbers all the way to 30, then the program doesn't change. For almost all the series addition problems, your program will have the same structure. Sum equal to sum plus something, and then your term changes. Whatever you're adding changes. So here, what I'm adding is reciprocal of the odd numbers. So what that means is I just have to write 1 over n. Now both n and 1 are integers, so that will give you a wrong answer. So you need to change to have a 1 point so that you will have the value correctly calculated. And also in this case, our sum has to be float, so I have to change my declaration. Other than that, the structure of the program is same, even to add the reciprocals. So what if I want to add squares of the reciprocals? 1 over 1 squared plus 1 over 3 squared plus 1 over 7 squared, all the way to 1 over 30 squared. What's the difference? Not much difference. The whole program will be the same. Only thing I need to change is Instead of 1 over n, 1 over n times n. Now it's 1 over n squared. I need parentheses there so that it will do the multiplication before the division. So that's it. That'll add up this series now. So very minor change you need to do to the entire structure. It'll be always sum equal to sum plus whatever you need to add, and then the whatever need to change, n or whatever that has to change. Something has to change to go to the next term of the loop, term of the series. So whatever that needs to change, you need to change. Other than that, the structure will be the same. You can always,
Okay.
yeah.
What if you have to change the top as well? Like the top is changing consistently, but the bottom is changing consistently. You have to create like a different variable.
This top is, you mean I changed my declaration of in to float. That's the only change I had to make.
I meant the numerator, like if it's 1 over 1 plus 2 over 3 plus 3 over 7 instead of just 1.
Okay, like for example, if I'm adding up, yes, that was the homework due today, right?
Yeah, we had a
Okay.
question like that.
All right, let me write that. This will have to be 1 over 2, 2 over 3, and so on, right? Okay, so it'll be n. N over n plus 1. How about that?
And then how does the n?
N changes by 1. N equal to n plus 1.
Okay.
So now it's 1 over 2. And then next time through, it'll be 2 over 3. Next time, it'll be 3 over 4. Okay. So,
Got it.
All right. Yeah. So it's always, very, it's not complicated. It's a matter of figuring out how to set up the variables. So that will add up 1 over 2, 2 over 3, and so on. All right, moving on to the next slide. Okay, I went over the program already. Okay, so this first one I just did right on the board. So this second warm-up exercise, I want you to do that. All right, so use the chat. Put your program in the chat. It's the structure of the program is exactly the same as what I wrote on the board. Only the numbers, the way numbers are changing is different. So how n changes is the only thing that's different. Now, by the way, you could always start. Let me quickly explain something. So in this program over here, I wrote 1 over. Erase this to go back to.
Is it? Oh, sorry.
Yeah, this term I changed. it was 1 over n squared. And let me change that back. And I need to explain something here. N times n. This will add up these this series, right? Now, if you don't want to compute this 1 over 1 squared for 1 over 1 squared, unnecessary work for the computer, you can just begin your sum at 1. So let me change that here. You can begin the sum at, instead of 0, I'm going to start with this value, the value of 1 over 1 squared as my sum. This 1 over 1 squared is equal to 1. So I'll start the sum at 1. And in that case, n has to start at 3. So n will be 3 now instead of 1. And still I'm doing the same thing. As long as n less than or equal to 30, I'll be adding, the first term I'm adding is 1 over 3 squared. And then n changes to 5. And then I'll be adding 1 over 5 squared, and changes to 7. So now I'm adding everything else. Sum started at 1 to hold this value. You can always do that. So it appears that would be better way to do the warm-up exercise 2. Have the 1 in the in the sum, the very first one, and then your first term, first term you'll be adding will be 1 over 5. This will be the first term you'll be adding. So that means your n, the number you need to hold in the, save in the n will be 5, right? The very first number you need to add is 1 over 5. So n will start at 5. Sum will start at 1. That'll be the better way. All right. Continue on and write your program. Okay, I have a program. Let me read that. I have one from Alexandra. Sum equal to sum plus n equal to n plus. Well, the n equal to n plus 1 is not going to work because n is, you're incrementing n by 1. So you're adding 1 over 5 and then 1 over 6 and then 1 over 7. That's not what we're doing, right? So the series you're adding is wrong. The n should not be incrementing by 1. It should change some other way. So see if you can figure it out.
Okay.
Should n change by 2? Is that the question, Vanessa? I finished the question. No, n should not change by 2 either. Look at the pattern. Look at the denominators and see if you can figure out how it changes from one denominator to the other and then to the other. It's always same pattern. There's a pattern in the way it changes. and you have to figure out the pattern. Okay, that's a little better thinking, but it is still not right. Let me explain why. If n is currently 5 squared, then n times n will be 5 to the 4th. That's not what we need, right? So keep working. Okay, smile. Count.
So what question are we doing? The first one, right? Homework exercise 1.
Second one. First one I already did on the board. Second one, warm-up exercise 2.
Gotcha.
I'm looking at Ismail. Okay. I don't see why you need a calendar, but you don't need the calendar. Oh, I see. Yes, you do need the calendar. Sorry about that. You do need the calendar, and that is correct. Very good. So Ismail has the right program. Now, others, work on your own program without looking at the ones on the chat. Another thing in this program that's different from the previous exercise is that you cannot control the loop by n. N becomes 5 to the 20 at the end. 5 to the 20 is something we cannot write in C++. So you have to use a slightly different method. And so what I suggest is control it by the power. Keep track of the power of 5 that you're adding. First, you're adding 1 over 5, then 5 squared. When you're adding 5 squared, your power should be 2. When you're adding 5 to the third, the power should be 3. So when the power becomes 20, you're done adding. When the power is 20, you're done adding. So the loop should be controlled by the power. Keep track of the power in a second variable. Only 2 students wrote. Okay, I have one more. Let me see, 1 over n equal to n times 5. Right. Adrian has the right program. Very good. So I have 2 students with the right program. One other student made an attempt, but it was not quite right. So Alexandra, hopefully you're working on that. The n equal to n times n is incorrect. You need to change that line. Other than that, everything else is good.
Professor, I'm showing a video of mine. Can you see it?
Yes, I see it. I'll put it a little bit closer to the camera. Down a little bit. Go down a little bit. Further, down. Move it down. Okay, now I see it. Bring it closer. Okay. Sum plus equal to 1 over n equal to n times 5 count plus and while count. Yes, you got it. That's right. Yeah, Christine has the right program. Very good. All right, so Alexandra, did you figure out how to change the n?
Yes, I just changed it to n times 5.
Right, okay. Oh yeah, okay, here's the name version. That is correct, very good. See, n equal to n times n doesn't work because when n is 5 squared, n times n will be 5 to the 4th, and that's not right. So you need to just keep multiplying by 5. That's correct, very good. All right, so 3 students have the right program, and yeah, 3. Well, 3 is too few, but it's all right. Let's go over that program. Now notice that our denominator is 5, and then it changes to 5 squared. Then it has to change to 5 cubed. That means I simply need to multiply by 5. Can you see that? Each denominator multiplied by 5 is what the next denominator is. And that's the pattern we need to take advantage of. You have to recognize the pattern, and then you need to take advantage of that. So I'm writing the program on the board. My sum is going to be float because they're all fractional numbers we are adding, float sum, and I'm going to start the sum at 1. And my first denominator is 5, so I'm going to start my n at 5, n equal to 5. And then a counter. I need a counter. I will make that integer, int count, or power I'll call it, because I'm basically tracking the power of 5 that I'm adding to sum. So power is initially, right now n is 5 to the power 1, and therefore power is 1. Always keep the power same as the power of the 5 that you're working with. Okay, so while we'll get back to the loop control later. Inside the loop, I need to add to the sum, I need to add, what do I need to add? Which is 1 over 5. 1 over n is what I need to add. So sum equal to sum plus 1 over n. After doing that, I need to make the change to n. N must change on the next line to go to the next term. To prepare for the next round of the loop, I need to change the n. So here n needs to change by multiplying by 5. N equal to n times 5. Multiply current n by 5, put it back in n. And my counter needs to go up to keep track of the power. So when I multiply n by 5 and put it back in n, my n has changed to 5 squared. At that point, power should change by 1. So power plus plus, and then close the loop. So with the new n that I computed here, n equal to n times 5, with that, I go to the top of the loop, and as long as the condition is true, I will add that 1 over n. Now n is 5 squared, so 1 over n is 1 over 5 squared. It's being added to sum, to the current value of sum. Then n changes to 5 cubed here, and tau changes to 3. And then the 5 cubed is added, and then n changes to 5 to the 4, and so on. So the power, when the power is 20, we are done. So that's why the power is going to control the loop. Power less than or equal to 20. When power is 20, I still want to add this. When power is 20, my n is 5 to the power 20, and I do want to add 5 to the 20. Then n will become 5 to the 21. Power becomes 21, and that's when the loop will terminate. Well, after the loop terminates, we need to see out the sum. Okay, so let's move on now to multiplying up. Write a program using a loop to multiply the numbers 1, 2, 3, 4 all the way to 20. Okay, multiplication is similar. Instead of sum, I'll call it prod, and then instead of adding, I'll have to multiply. That's the only difference. So let's do that problem. So I will start my variable pow at 1. Oh, everything is integer here, so int pow equal to 1. Now, when you're doing adding up, the sum will start at 0. When you're multiplying up, you have to start at 1. And then the number we need to multiply is 2. The very first number I need to multiply is 2. So n will be 2. And do I need any other variable? I don't see anything. So while the n goes up to 20. So while n is less than or equal to 20, pow equal to pow times n. So current value of n is 2. So 2 will multiply this. And after that, n should change to 3. So that next time through the loop, I'll be multiplying by 3. So I can just put plus plus behind this and they'll do it. And that's all I need to do to multiply up all those numbers. And when the loop finishes, see out prod. Okay, so let me trace the loop to show you how it works. My prod is, I called it pow for some reason, prod. My prod is equal to 1 at the beginning, n equal to 2. So n less than 20 is true. You have to make sure that initially, the first time, the condition of the loop is correct, is true. Only then the loop starts. So this condition is true. So therefore, this will be done, which means I'm multiplying by 2, multiplying the current value of prod by 2 and putting back in prod. Current value is 1. So 1 times 2 goes back in the prod. After that, n changes to 3 right here because of the plus plus. With that, I go back to the top of the loop, check the condition. It's true. So 3 is multiplying the prod. Current value of prod is multiplied by 3. Current value is 1 times 2. So that will be multiplied by 3 and that will go back in the prod. Now n changes to 4. And next time through the loop, the condition is true. So I'll be multiplying by 4. So now I have 1 times, 2 times, 3 times 4 stored in prod. And n changes to 5. So you can see that it keeps multiplying, and so it's working. At the last step, n will be 20, and when n is equal to 20, still the loop will go. So 20 will be multiplying the prod. Then n will become 21, and the loop will stop after that. Okay, so
Professor, what's that last line of code you wrote where it starts with a C?
see out prod.
Thank you.
Mhm. Okay, so warm-up exercise 1. All right, I want to see if you can write that. Multiplying up these numbers. If you look at the numbers, there's the pattern, and you need to use that pattern to change your n. The n, the number you're multiplying by, has to change to the next one inside the loop. And to do that, you had to take advantage of the pattern. Okay, I'm still waiting. Okay, I see one on the board on the camera. Let's say equal to 100 prod equal to prod times. The n plus plus is not going to work. So you need to stop at prod times n, and then on the next line change the n. You cannot increment by one. That's not going to work. Okay, so the n plus plus. I'm talking to Vanessa. The cross out the plus plus. Just stop at prod times n and semicolon. On the next line, write n equal to whatever you need to do to n to go to the next one. It's not going to be incrementing by one. You can see that if n was originally 5,
Right.
it has to become 10, not
Right.
6, right? You're making it 6.
Okay, got you. Yeah, got it. Thank you.
Mhm. The n has to be 5 initially, and then it'll have to change to 10 and then 15. You can see the pattern. All right, I see 2 in the chat. Let me see. Okay, 1 over n. That's all the one. Okay, I see Alexandra's solution. And that's equal to 10 per times n equal to n plus 5. Right. Alexandra, you got it right. Very good. I'm looking at Michael's n less equal to 100 per times n equal to n plus 5. Yes, Michael, you have it right, but you need brackets around the two statements because if you don't put bracket, only one statement is in the loop. You need both of them in the loop. Okay, I see Jean has a solution, product times 1. That is correct. Okay, Jean has the right solution. Kristen, right. Okay, very good. Excellent. So far, 4 students have it right. That's good. All right, so let me explain that. See, this is going to be very much similar to what I have already written on the board. So let me make the modification to what I have written here. This n plus plus has to change. N is not going up by 1 anymore. So I'm going to change these lines. And also n is going to be 5. So very first number has to be 5 now. The very first number we need to multiply by is 5. So put 5 in n, and then prod equal to prod times n. And I cannot change the n here. I had to change it on a new line. How is n going to change? N is going from 5 to 10 and then to 15. So clearly going up by 5. And so n equal to n plus 5. And I need brackets because I have 2 statements inside. And then that's it. That'll multiply up all of those. N is initially 5. So I'm multiplying by 5 and putting back in prod. And then n changes to 10. And next time through the loop, I'm multiplying by 10 and then changes to 15 and so on. So when the loop finishes, see out the prod. Okay, so instead,
Professor, I have a question.
yeah.
Can you make, because the way I wrote my program, I made prod equal to 5 in the beginning and n equal to 10.
Oh, yeah, that's absolutely correct. Nothing wrong with that. Yeah, let me explain that to everybody. What Christine did was she changed the prod to 5 and n to 10. So that way, the very first multiplication you're doing is the prod is starting at the very first number that is in the product, which is 5, and then n starts at 10. And still, the rest of the program will be same, and it'll still do the same thing. And that is absolutely correct. That's just a different version of the same program. So, of course, there are a variety of different things, different versions you can create for the same program, and they're all correct. So it is right. Now, we can skip the next exercise. We don't need that. Let's go on to, yeah, let me use this example to illustrate something. Suppose that instead of saying instead of multiplying all the way to 100, if it says determine how many of these multiplications should be done, or how many, this same program, 5 times, 10 times, 15, there's no end, there's no 100 at the end. It's infinite series. So in the second version of the program, the series is infinite now. It's going to be 5 times 10 times 15 times ... infinite. And now the problem says, determine how many of these multiplications should be done so that the product is just over 100,000. The product is just over 100,000. Okay, then the program is going to now slightly change. So I'm going to make those changes in this existing program. The condition is no longer less than or equal to 100. I mean, the n in that condition, n should have been n less than or equal to 100. I don't know, I had a 20, I think. That should have been 100. Anyway, that condition is now going to change. And also I need to count how many of these are being added. So I need a counter, because the question says how many multiplications should be done so that the product will be going over 100,000, to go just over 100,000. So I'm going to start my multiplication at prod at 1, because I need to count all the multiplications. So therefore, I'm going to start with the very first multiplication. Very first multiplication is 5 times 10. All right, so I need to start my prod at 5 and n at 10. Then 5 times 10 will be the first multiplication. So I'm going to introduce my counter at 0. And right after multiplying prod times n, I need to increment my counter. So I'm going to do that right there. Count plus plus. So that'll be count, 1 second. All right, multiply by n and then count plus plus. To mean, I just did one multiplication, so my counter should go up. So I set the counter to 0 there so that as soon as I do very first multiplication, counter becomes 1. And after that, n should change, n equal to n plus 5, and close the loop. Okay, so this time I'm multiplying by n and counting how many multiplications are being done. And then the loop control is the product is going to control now, because the problem says how many of these multiplications should be done for the product to go over 100,000. So you need to say while prod is under 100,000, keep going. That way, when the loop ends, the prod is over 100,000. And at that point, you need to write the count. When the loop ends, the count is our answer. See out. See out count. So,
Professor,
yeah.
does it matter if you put count plus plus after the n equals n plus 5?
No, it doesn't matter really, but I wanted to, when I was explaining, I wanted to put it in the logical order. But what you have inside the loop can be in any order in this case, but not always. Of course, n equal to n plus 5 should be after prod equal to prod times n, right? Because the current value of n, which is 10, should multiply. Only after that, n should change to 15. Other than that, the count plus plus can be anywhere in this loop.
Okay, thank you.
All right, yeah. Okay, so moving on, that finishes this section, this part of the 4.5. 4.5 is not finished. It's just one part is finished. I have, because this 4.5 is bigger than other sections, so I divided into two different presentations. By the way, in my other class, the students, some students didn't know that these PowerPoint presentations are available on Blackboard. Class by class, these presentations are posted on the Blackboard. If you need to review, you can always open it up and review that. So we are continuing to do the same section 4.5. Now we're going to do some more examples. But before that, let's introduce this operator. X plus equal to y, this operator means x equal to x plus y. It's just a small improvement, not a whole lot. Instead of having to write x twice, you can write this as x plus equal to y. And similar to that, all other operations, arithmetic operations, have similar operators like these. These plus equal, x plus equal to y means x equal to x plus y. Similarly, x minus equal to y is there. That means x equal to x minus y. X star equal to y means x equal to x star times y. And also slash, modulus. For all the operators, you have the corresponding arithmetic assignment. These are called arithmetic assignment operators. It just adds a small convenience, that's all. But where do they belong in the order of operations? All right, let me clear the board and explain something. The order of operations, you already know pretty much everything. Always, the very first one will be negation. Negating operator will be the first, after that parentheses, and then arithmetic multiplication, division, and modulus, all those. So let me just use a simple example. If I have x equal to, if I have an assignment statement like x equal to y plus z times 7, then think about the operations that will be done first. The multiplication will be done first, and then it'll be the addition, so it'll be added to y. Only after that, the result will be assigned to x. So the assignment operation is always the last one. Everything on the right side of the assignment will be done first. Even if it is something like y greater than or equal to z plus 7. Even then, the greater than or equal to operator will be done after the arithmetic operation. So after doing z plus 7, it'll evaluate the inequality. And the result will be true or false. And that true or false will be assigned to x. So if I write x plus equal to y greater than or equal to Z, something like that. Still, this will be done first, and then it'll be added to X and stored in X. So the plus equal to operator is just like the equal operator. It's always done last, after everything else is done. So in the order of precedence that I'm going to show you next, you can see that arithmetic, the assignment and the arithmetic assignment operators are at the bottom because they will be done last. Before that, parentheses, the plus, plus, minus, minus, and then multiplication, division, and modulus. If there are more than one, it'll be do left to right, and then the plus minus. Only after that, comparisons. Like I said on the board, after doing the z plus 7, the comparison will be done next. So comparison will be after the arithmetic operations. And after that, the equal, or not equal comparison, and then arithmetic assignment operations. So that'll be the last. All right, so they're logical. You don't have to sit down and memorize them. They're fairly easy, but almost all the time we put parentheses anyway. So if you put parentheses, then it'll follow the parentheses. All right, let's do the next example. Write a program to compute the sum of this series, 2 squared, 2 cubed, all the way to 2 to the 10. We did something similar, but I'll go over quickly. We need to start our variable. These are terms that we're going to add up. So you need to take advantage of the pattern. From each term to the next is just 2 times, right? If I multiply 2 squared by another 2, I'll get 2 cubed. If I multiply that by another 2, I get 2 to the 4. So it's just multiplying by 2. So I'll start my int prod. Oh, sorry, not prod. We are doing sum. Sum equal to 0 and n equal to 2. And then while we'll come back to the condition, we need a counter. So I need to introduce count equal to 0. And we'll come back to the loop control. I need to do sum equal to sum plus. So I can write sum plus equal to n. So n is currently 2. I'm adding that. And after that, I need to change my n to go to the next term. And that'll be, okay, what do I say? How do I change n? Anybody?
N equals n times 2.
N equal to n times 2, right? And I need to increment the counter as soon as I add this. The reason for counter is because how do I control the loop? When n becomes 2 to the 10, I'm done. But I cannot write 2 to the 10 in C++. So therefore, I cannot say while n is less than 2 to the 10, keep going. I cannot do that. So therefore, I introduced my counter variable that'll keep track of the power. So my count was, I had 0, I should change it to 1 because initially n is equal to 2, which is 2 to the 1. So therefore my power should be 1. And when n changes here to 2 squared, my count, which is power, must change. So plus plus, count plus plus. The count is now keeping track of the power. And so now we can control the loop by saying count as long as count is less than or equal to 10, keep doing it. So while count less than or equal to 10, it'll do it. And when count becomes 11, loop will terminate. So now it'll be adding up those terms. Okay, moving on to, I already did the program. Okay, let's do this one. Now remember, the series may look complicated, but your program is not. The program is pretty much like this always, and about the size of this program that I have on the board. It will be always about the size of this program. So whatever you need to add it, and then make the change to the things you're adding and increase counter if you need to count. Sometimes you don't need a counter. So it's pretty much the same structure for all the series addition problems. So let me clear the board and start over. So look at the terms. The denominator is 2. Numerator is not changing at all. So I can keep I don't have to keep track of the numerator. Denominator is initially 2, and then it changes to 2 times 3, and then changes to 2 times 3 times 4. So that means I need to have a multiplier because I need to multiply the first denominator by 3 to get the second denominator, and multiply second denominator by 4 to get the next one. So that means I need a multiplier which has to change. Initially, the multiplier needs to be 3. Can everybody see that? From this denominator, first denominator to the second denominator, I need to multiply by 3. From this to the next, I need to multiply by 4. So the multiplier itself has to increase by 1. And that's what I need. So I'm going to introduce a variable for denominator. I'll call it den or denominator. And I'm going to make them all float. Float then to mean denominator equal to 2, sum equal to 0, and multiplier, I will call it m, equal to 3. The first value of m needs to be 3. Okay, and then while, we'll come back to the loop control later. While something is true, I need to add sum to the sum. I need to add what? 1 over n. So sum plus 1 over denominator. I called it den, so 1 over den. That will be 1 over 2 I'm adding. Right after that, I need to make the change to the den to go to the next one. Okay, what do I write? Anybody? I need to change the den to go to the next denominator.
And do plus plus after the den.
Den plus plus, no, the denominator is right now 2, and it's not going to be 3 for the next one. Denominator is not going to be equal to 3. The denominator, current denominator, which is 2, should be multiplied by a number to get the next denominator. And that number that I need to multiply by is right there in the m, right? So I need to multiply the denominator by a number to get the next denominator. How do I write
So
that?
should it be den equals den times m?
Den equal to den times m, right? Den equal to den times m is correct. Okay, after that, so now it's 2 times 3, right? Den is 2 times 3. And so if I go back and redo this loop, I'll be adding 1 over 2 times 3. That'll be correct. But I need to change my m to prepare for the next iteration of the loop. What change do I make to m?
Add plus plus.
Plus plus, right. M needs to increment by 1. The multiplier is currently 3. I multiplied by 3 to get the next denominator. Now I need to change the multiplier to prepare for the next iteration of the loop by incrementing by 1. So m needs to increment by 1. And so I need to put m plus plus right there. So m plus plus here will make it increment by 1. And now you can see if I close the loop, it's going to work. So next iteration of the loop will be adding 1 over den, which is 1 over 2 times 3. I'm adding 1 over 2 times 3 to sum, and then multiplying denominator by 3. M has already changed to 3. I'm sorry, 4. M has already changed to 4. I'm multiplying the denominator by 4 so that next time I'm adding 1 over 2 times 3 times 4. So it keeps, so let me go back one more time. Initially denominator is 2 and 1/2 is being added to sum, and then denominator changes to 2 times 3 and m changes to 4. M changes right there to 4. So next time I'm adding 1/2 times 3 and denominator is multiplied by 4. And then m changes to 5. So clearly we are adding up those. Well,
Professor, what's the value of sum initially?
0.
Thank you.
So sum, let me trace that quickly here. Sum was 0 and denominator was 2 and m was 3. So I'm going to show you how they changed. Sum was 0. So with that, this will be executed. So 1/2 is added to sum. So sum becomes 1/2. And then denominator changes to denominator times 3. M is 3 right now. So I have 2 times 3 for the denominator now. And m changes to 4. And then go back to the top of the loop. If the condition is right, condition is true, then I'm adding 1/10. 1/10 is 1/2 times 3. So to the current value of sum, which was 1/2, I have now added 1/2 times 3. And so 1/2 times 3 is added. And then denominator is multiplied by the 4. So now the denominator is 2 times 3 times 4. And m changes to 5. And now go back to the top of the loop. If the condition is true, then you're adding 1/10, which means then now has all these added up. And then the den changes to 2 times 3 times 4 times 5. And then the n changes to 6 and so on. So you can see that it is adding up the right things. So how do I control the loop? What's the loop control condition? Anybody?
Well, then is less than or equal to 10.
Not the den. Den is initially 2, and then it's 2 times 3, and then 2 times 3 times 4. That's already bigger than 10 right here. It's not the den that should be controlling.
Oh, m.
M, right. When m becomes 10, the multiplier becomes 10, you're done. So while m is less than or equal to 10, when m is equal to 10, means we have multiplied, our den is right now 2 times 3 all the way to 10. That's when m equal to 10. And so we do need to add that. And then when m becomes 11, we need to stop. So so m controls the loop. All right, moving on. So as you can see, the program is not big. It's just the same size as previous program. It's just the way you can change the denominator, the way you change your term is going to be different in each problem. Other than that, the loop is essentially same for every problem, no matter how complicated the series might be. Okay, so moving to the next one. If the question says how many of these terms should be added up for the sum to go over 0.7182, so now the question is slightly different. So in that case, what you need to do is, now it's infinite series, so it's not m less than or equal to 10 is no longer true, but we need to increment counter. We need to have a counter, so introduce a counter and set it to 0 and increment the counter here. And then the control of the loop is going to be, while sum is, the sum will be controlling now, because the problem says you need to determine how many of these additions should be done for the sum to go over 0.7182 means while sum is under 0.7, we need to keep going. Only when the sum goes over it, the loop should terminate. So when the loop terminates, sum is over the number 0.7182. At that point, the counter has our answer. So C out count. That's the only difference. The sum will be controlling the loop now, and you need a counter to count how many have been added up. All right, already did that. Okay, so let me see if you can write this program. Okay, I should say sum equal to sum plus what? Anybody?
Is it 1 divided by 10 times 10? Or, oh, you don't have 10, sorry, n.
N, you're right. N times n is right. Very good. N times n. And after that, n should change to go to the next term. How do I change n?
+3.
Plus 3. So n equal to n plus 3 will do it. So right now n is 1, and 1 over 1 squared was added to sum. And after that, n changes to 4. So that next time through the loop, I'll be adding 1 over 4 squared. So I need my counter to count how many things are being added up. So I increment my counter here and close the loop. Okay, now what's the loop control?
Well, the sum is less than or equal to 1.6.
Right. that's equal to 1.6. So while sum is under 1.6, I need to keep going. Okay, very good. Next thing we need to understand is, instead of telling you to control the loop by sum, they can say, add up this series accurate to 5 decimal digits. So if I say, it's an infinite series, but I cannot go infinitely many times. I have to stop somewhere. So how do I stop the addition? I have to keep adding as long as my term, you can see that this half compared to half, this second term is smaller. I'm dividing by another 3. And the third term is even smaller. I'm dividing by another 4. So the numbers are getting smaller and smaller. So eventually it'll be too small to add. That's when we stop. So when the problem says add up this series accurate to 5 decimal digits, I'm going to explain that I don't have to write the program for that series. We already did that earlier. So I'm going to work with this program I just did. This series 1 over 1 squared, 1 over 1 squared plus 1 over 2 squared plus 1 over, 4 squared plus 1 over 7 squared. This series is now infinite series. And the problem says add up this series accurate to 5 decimal digits. You can see that 1 over 4 squared is 1 over 16, which is a small number. The next one is even smaller, 1 over 49. So the numbers are going smaller and smaller. So at some point, it'll be too small to add. And what would be too small? The problem says accurate to 5 decimal digit. That means if the series, let's say I have added the series, and now I have something like this. 5 digits are there. And the next term, which is somewhere here, 1 over 29 squared or whatever the term is, the next term calculates to be something like this: 50, 60, and then 2. So adding this number to the sum I have here will not change these 5 digits. 5 fractional digits will not change by adding this. So that's when we stop, because we already have 5 decimal accuracy. This new term is not going to change it. So how do I do that in my program? In the program, I need to say, keep adding as long as I need to make a small change. I need to calculate the term, the 1 over n times n right here. This has to be calculated and stored somewhere. And I'm going to do that. So let me say term. I introduce a variable called term, and term equal to initially 1 over, no, I don't have to calculate that up here. I can say term here, term equal to 1 over n times n. And then sum equal to sum plus term. I had to calculate the term and store it somewhere. Other than that, nothing else changes. So the term, I have to use the term to control the loop. I keep adding these as long as term is big enough. So while term is greater than greater than 0.00000, that's 5 zeros. 60. If the 6th digit is also 0, then adding that number will not change 5 digits. So while term is bigger than this, keep adding. At some point, the term will be smaller than this, and the loop will terminate. So when the loop terminates, we have already added up the numbers accurate to 5 decimal digits. So you write the sum at that point. So 5 decimal digits accuracy means you have to have 6 zeros in your number, in this number, and then 5 after that. So if your term is smaller than this, it's not going to change 5 digits in the sum that you have. If they want 6-digit accuracy, then you need to make sure you have 7 zeros in this number. Only then it will not change. So that's how you check for 5 or 6-digit accuracy. All right, so that is our, yeah, that's all we need to do before the test. This topic that begins next is not going to be part of the test, and it's not in your homework or your review. So we have completed all the topics that the test will cover. Everything up to here that we have, everything we have done so far will be on the test. And you have a homework today that's due Wednesday. And before Wednesday, you need to do your review that is posted on your course supplements, and bring up your questions for discussion in the next class. The following class will be test. So test will be Monday. I can give you extra half an hour. So you will have half an hour extra time if you have the time. So if you don't have the time after this class, then you can start the test with the other class. The other class is starting the test at 7:30. So if you have another class after this class, then you don't have extra time that you can use. So in that case, you may want to join the test in the morning at 7:30. So if you're joining in the morning, then you will need a password, and I will provide that for those who are present in the morning test. All right.
Professor, can I talk to you about the project really quickly before you end class?
Well,
So
I'm going to close the class, and then you can hang on. We can talk. All right. So
Me too, Professor. Me too.
all right, then hang on. All right. So for the others, we are all set. Next class will be discussion, and the following class will be test. So enjoy the rest of the day, and we'll see you Wednesday.
Thank you.
You're welcome. Bye now.
Bye, Professor. Thank you.
You're welcome. I'm keeping the meeting open for those who have questions.
Professor, I have a really bad. I had a problem. I don't know this. So basically, for my project, I ran into a problem where I finished on time, but then since I ran out of time and like my browser wasn't working for the past 20 minutes, I was like figuring out how to submit it because my router wasn't working, and I came to
During the
conclusion.
class, you have been working on your project?
No, not during the class.
Yeah.
This was before your class. I submitted the program,
But I
but
know
I emailed it.
not in class.
Huh?
You're not in the meeting.
I was in the meeting the whole
You were
time.
in the meeting at the beginning, and then at some point you disappeared.
No, I disappeared for like 1 minute because I switched devices.
Uh-huh.
But basically,
After that you were back?
what do you mean?
You mean after you switched the devices, you were back in the meeting?
I wasn't even gone. It was basically I wasn't even gone. I logged in from one computer
I don't know what
to my.
happened, but Zoom was telling me that you left the class.
I did left. I left and I joined back on another device because my router and everything was fixed again.
Okay.
um
Doesn't
so
matter. Yeah, go ahead.
But basically,
I fucked up. I didn't look at the updated textbook page for the project where you said to only calculate for the 30th and 45th term. I calculated for the 60th and the 110th.
oh, I also did too. I'm sorry. Yeah,
Why didn't you make those changes?
I didn't look at that till like this morning. And when I wrote my program, I noticed that like when you regularly do a regular initialize, the outcome would it really pop up with the correct sequence for the 60th and 110th term, because those numbers were way too big. So for the 60th term, I used the what was it? For the 60th term, I used the unsigned long initialization and it worked. But for when it came to the 110th term, I couldn't get like an integer value because
Yeah, those numbers
unsigned.
are too big, and that's why I changed those numbers to.
Yeah, I didn't look at that. That was my bad. But I used for 110th, I used long double, and it gave me the decimal with the eon. number, and it worked because compared to what I seen online for the 110 term. But like, how many points will I get taken off for that? Because my program works, but
That's
like,
not yet, but if you didn't produce the numbers as for by the new version of the project, then you will lose some points.
can I
Other,
resubmit with the
I suggested making all those changes right at the beginning of the course, right? I explained to everybody, you need to make those changes throughout the book so that you won't run into wrong problems and wrong statements. Okay.
So
And
should I resubmit like with the 30th and 45th? Because I already submitted it like last night. Said
okay. And that's it. No, that was your mistake. I even pointed that change in my description of the project, in my link. In the link, it says right there were changes to this project.
no, on Blackboard, no, I didn't see that. Because if I usually you
There,
usually do it
the
on
link,
Blackboard, like on like assignment, submit assignment. I didn't see it. That's why I didn't even look for it.
the link says that right there. And so I have done everything to warn you, and you didn't do that. So now, no, I cannot accept late project. I don't. Then I had to accept it from others. So I don't. I don't want to
I
do it.
already submitted the project. That's the thing.
All right. Yeah. So you lose some points, but it's not going to be zero. So you're fine.
Okay.
Okay, never mind. Then that disregards my whole problem too. Then.
You have the
My-
same problem.
Well, that and a little bit more where I ran into an issue with my router, so I had to figure a way out to submit it. So I ended up just emailing it to you from my phone. But
Okay, so
there's no point of that. That doesn't matter anymore because I had the same problem as Christopher where I didn't read it
project
properly either.
your project wasn't working.
No, it's not that it wasn't working. It was I didn't make the corrections either, and I wasn't able to. I submitted like 1 minute, 2 minutes late because I emailed it instead because I ran out of all options and I basically ran out of time to figure out how to submit it.
Yeah. Why? That's because you waited too long. I gave you a whole week, right? Why did
Yeah.
you wait so long? And why is everybody starting the project at the last minute? I only see like 2 students submitting early, and everybody else is waiting until last minute. I don't know why, and I can't seem to be able to change that. So if you waited until last minute, then you have to suffer the consequence. Okay.
Peace out, Mr. Professor. My bad.
All right. Okay.
All right, Professor. I talked to you.
All right. Okay. See you later. Anybody else with questions? Okay.